Assalamualaikum and good day everyone. So today we will continue with chapter 4, which is Fourier series. If before this we have learned on solving our integrals or solving differential equation by using Laplace transformations, so today we will see on the topic of Fourier series, where many functions can be expressed in the form of infinite series. Okay, so the important to learn on Fourier series, because Fourier series can be used for solving the integrals of a function. Okay, and the advantage of Fourier series is that it can represent many functions where it can be represented in the infinite series. Okay, so that's why we want to learn on how about the Fourier series and how to solve the integrals by using Fourier series. Okay, so we will start with the subtopic 4.2 first, which is even and odd function. Then we will go to 4.1, which is the periodic function. So for even and odd function, you have to know three different functions. Either it is even functions or odd functions, or neither even nor odd. Okay, so how to know about even functions? Okay, so if you are given a function ft, for example, if we want to check whether ft is even function or odd function, you need to substitute your t with negative t. Okay, when you are substituting your t with negative t and you get your f negative t is equal to ft, so that function is called as even function. Okay, so a function ft is said to be even if you have your f negative t is equal to ft. Means all t that you have in your function substituted by the negative t. Or if you represent your function in graph, you will get the symmetric graph about the vertical axis. So what is the vertical axis? Vertical axis is the y-axis wherever point of y. Okay, so vertical axis is the y-axis wherever point of x. Okay, means that you can have your vertical axis at your original y-axis here. You can also have your vertical axis at x is equal to 1 here. Okay, so when you plot your graph and you see that your graph is symmetric at vertical axis, means your function is even function. Okay, later we will see. So what is the important things that you need to know is two things. The first one, to know that our function is even function, when you substitute your t with negative t, you will get your function f negative t equal to ft. Okay, this one is the first one. Or you can also plot your function and you can see that if the graph that you plot is symmetric as vertical axis, it means that your function is even function. Okay, and how about odd function? If we are substituting our t with negative t, but we didn't get our f negative t equal to ft, okay, but we can take out the negative sign and we can see that f negative t is equal to negative ft. Okay, so this means that our function ft is equal to odd function. Let me give you example. Okay, let's say you have ft equal to t. Okay, now you want to check, ft equal to t squared. So now you want to check whether your function ft equal to t squared is even or odd function. What you need to do is you need to substitute all t with negative t. So let's find our f negative t. So when we substitute our t with negative t, what you will get here is negative t to the power of 2. So negative t to the power of 2 will give you t to the power of 2. So what you can see now, your f negative t is actually equal to your function, the original function ft here. Okay, so what we can conclude here is our f negative t is equal to ft. Therefore, your function ft here is even function. Okay, and if you plot your function ft equal to t squared, you will get the quadratic function like this. And the quadratic function is clearly symmetric at vertical axis. That's why this one is a even function. How about we have ft equal to t to the power of 3, for example. Okay, so if I have ft equal to t to the power of 3, let me show you. Okay, so now we have our function ft equal to t to the power of 3. Okay, then we want to check whether this function is even or odd. So we just need to substitute our t with negative t. So what you will have is f negative t is equal to negative t to the power of 3. So negative t to the power of 3 will give you negative t to the power of 3. So you can clearly see that your f negative t is not equal to your ft because your ft is t to the power of 3. But what can you see now is f negative t is actually negative ft. Okay, because your ft is t to the power of 3 and your f negative t is negative t to the power of 3. Therefore, you can conclude that f negative 3 is actually negative ft. Means that this one is odd function. When you plot your ft equal to t to the power of 3, you can see that you will get the cubic graph here. Okay, and cubic graph is symmetric about origin. What means symmetric about origin? You will get the same graph when you reflect at the axis x and y. Okay, for example, let's say I take this curve. Okay, I reflect it at y axis, so you will get the curve here. Okay, then you reflect it again at the x axis, what you will get is the curve here. Okay, so when your curve is reflected at x and y axis, means that your curve is reflected as origin. Okay, or symmetric at origin. Therefore, this one is odd function. And then the third one is neither odd nor even. Means that when you substitute your t equal to negative t, you will not get your f negative t equal to ft, and you will not get your f negative t equal to negative ft. Means that that function is not even, is not odd. So we call that function as neither odd nor even. When you plot the graph is not symmetric at origin, and also is not symmetric at vertical axis as well. Okay, so you have three types of function here. The first one is even function, the second one is odd function, and the third one is not even, not odd, that we call as neither even or odd. Okay guys, let's say on the example to determine whether our function is even, odd, or neither even nor odd. So let's say the first one, when we have ft equal to cos t. Okay, so now you have your function ft equal to cos t. So you want to check whether your function is either even or odd, or neither even or odd. So what we need to do is we need to substitute our variables t with the negative t. So now you will find what is f negative t. So let's substitute all t that we have in this function with negative t. So what you will have here is cos negative t. Okay, and by the trigonometry identities, you know that when you have cos negative variable, it will be positive. Okay, where cos negative t is actually equal to cos t. So what you have here is f negative t is equal to cos t by using the trigonometry identities. Therefore, what you can see here, your f negative t is equal to your ft. Okay, so you have your f negative t equal to ft, means that your function, the first function here, is even function. Okay, so let's say the second one, we have ft equal to sin t. Okay, ft equal to sin t. Now we want to check whether this one is even, odd, or neither even nor odd. So let's substitute our t with negative t. So we have f negative t. So we have here is sin negative t. So sin negative t is equal to negative sin t. Okay, so you can see that your f negative t is not equal to ft, but your f negative t is equal to negative ft. Okay, therefore the second function here is odd function. Okay, so let's see the third one. Okay, when we have ft is equal to exponent t. Okay, so now we want to check this function, so we need to substitute t with negative t. So let's find f negative t. So f negative t is equal to exponent negative t. Okay, so this one is not equal to ft, not equal to negative ft as well, because negative ft will give you negative exponent t, but you have exponent negative t. So it's not equal, your ft is not equal to f negative t, sorry. Your f negative t is not equal to your ft, also not equal to yet negative ft. Therefore, your function ft equal to exponent t is neither even nor odd. Neither even nor odd. Okay. Let's say the fourth function here, we have ft equal to tan t. So if you can remember, tan is equal to sine over cos. So let's write our function ft equal to sine t over cos t. Okay, for this fourth equation, so we have ft equal to tan t, and we know that tan is equal to sine over cos. So we have ft equal to sine t over cos t. Okay. Then we want to check whether this function is even, odd, or neither even nor odd. So let's substitute our t with negative t. So what you have here is f negative t equal to sine negative t over cos negative t. Okay. By trigonometric function, sine negative t is equal to negative sine t. So you have negative sine t here on the numerator. And cos negative t is equal to cos t. Therefore, you have cos t in the denominator. So what you have as your f negative t is negative sine t cos t. It's not equal to your ft, but it's equal to negative ft. Because you have ft equal to sine t cos t, so your negative ft would be negative sine t cos t. So f negative t is equal to negative ft. Therefore, our function, the fourth function here is okay. So same goes to the equation number 5. What you have here is ft equal to 2t to the power of 4. Let's check whether this one is even or neither even nor odd. So we have ft equal to 2t to the power of 4. Your f negative t will be 2 times negative t to the power of 4. Negative t to the power of 4 will give you back t to the power of 4. Therefore, your f negative t is equal to ft, means that our function here is even function. Okay, and the last one here, you have ft equal to modulus t. So ft equal to modulus t. So let's substitute our t with negative t. So what you have here is f negative t equal to modulus negative t, which give you back the positive t. Okay, so your f negative t is equal to your ft, means this one is even function. So this one on how you can determine whether your function is either even, odd, or neither even nor odd. Okay. Okay guys, so one more method to determine whether our function is even, odd, or neither even nor odd is by using or by sketching a graph. So let's say we have a function, this one called as a piecewise function. Given to you, your function ft is ft plus 2 pi. And it's given to you that when your t is equal to 0 to negative pi or negative pi to 0, you have your value of ft is equal to 2. Okay, and when you have your t is from 0 to pi, your ft is equal to negative 2. Okay, so when you sketch your graph, you will get this kind of graph on the right side here. Okay, so you can sketch the graph and you will get what the graph that I have in right side here. So what you can see is this graph is symmetric about origin. Okay, what means by symmetric about origin? When you reflect it to the axis y and x, you will get the same graph. Okay, so let's do the reflection of this graph. Let's say we take one part here, the one in the this one on this side. Okay, let's reflect this graph on x-axis first. So when you have your graph here, so the reflection about x-axis is here. Okay, then you have your graph here, and the reflection about x-axis will be here. Okay, and you have your graph here, the reflection of this graph about x-axis is here. Okay, that one is about x-axis. Then when we reflect it about y-axis, this graph will give you the reflection here, this graph will give you the reflection here, and this graph will give you the reflection here. Means that this graph is reflect or symmetric about origin. So when your graph is symmetric about origin, it means that your function ft is odd function. Okay, So this one is the one of the method that we can use to determine whether our function is even, odd, or neither even nor odd. Okay, either then we use the function ft equal to f negative t or ft equal to negative ft before this. Okay, so for the second one, also this one is a piecewise function where you will have your ft equal to 0 when your t is from negative pi to negative pi over 2. Then you have your ft equal to 3 when your t is negative pi over 2 to pi over 2, and you have your ft equal to 0 when your t is equal to pi over 2 over 2 pi. So when you sketch this graph, what you get is this one. Okay, so when you see this graph, you can see that this graph is actually symmetric about vertical line. Let's say I draw a vertical line here. Okay, or we take the x-axis, the y-axis as our vertical line. So this graph have its reflection here. This graph has its reflection here. So means that our graph here is reflect at or about vertical axis. So when you have your function, the sketching of your function reflect about the vertical axis or symmetric about vertical axis. So this function is odd function. Even function. Okay. So you need to remember that if we are using the function, okay, when f negative t is equal to ft, then you have even function. Or when you sketch the graph, you will get the graph that's symmetric about vertical line or y-axis. So this one is a function, an even function. Okay. And if we have our function f negative t equal to negative ft, means this one is an odd function. Or when you sketch your odd function, what you will get is the graph that's symmetric about origin. Okay, where symmetric about origin is the graph that reflect at x-axis and y-axis. Then if we have a function that is not symmetric at vertical line or even symmetric at origin, so this function will be neither odd nor even. So if you see this function, okay, the third graph here, if we draw a vertical line, let's say I draw a vertical line, I take the y-axis as a vertical line. If you have this graph, you should have a reflection here if it's symmetric about vertical line, but it's not, so it's not symmetric about vertical line. Same goes to the symmetric about x-axis, symmetric about origin. So if you reflect your graph at x-axis, this graph will give you this line, and when you reflect it at y-axis, it should give you this line, but don't have in your graph. Therefore, this is the graph that not symmetric at origin and not symmetric at vertical line as well. So your function is neither odd nor even. Okay, if you have we use the function f negative t, you will not get f negative t equal to ft, and we also not get your f negative t equal to negative ft. So this is the neither odd nor even function. So this is how you can determine your function either is even, odd, or nor neither odd nor even by using graph.